So, good evening, everybody. Here, the BET group welcome you to another of our lectures. This time, we have as our lecturer guest Edith Newton Wilson. Edith is the owner of Rock Whisperer LLC, where she works to engage emerging professionals in energy solutions for a changing world. Edith is a fellow of the Society of Economic Geologists and the Geological Society of London. She is the president of the Energy Minerals Division of the American Association of Petroleum Geologists, AAPG, past president of the Tulsa Geological Society, and a founding member of the Geosciences Advisory Board at the University of Arkansas. She received her bachelor in geology from Dartmouth College in 1982 and her master's and PhD in carbonate sedimentology from Johns Hopkins University in 1988. Her career in the energy industry began in Houston, where she was an international explorer, negotiator, and manager with Amoco and BP. In Oklahoma, Edith worked with Phillips Petroleum on global new ventures, with ConocoPhillips on leadership development, and with Samson Resources on domestic shale gas projects. In 2008, she co-founded Tallgrass Energy, which acquired and operated oil and gas properties in Oklahoma and Texas. Today, Edith consults on renewable energy and climate mitigation projects. She has traveled throughout the Americas, Europe, and Africa, and I cannot stop being amazed all the time I read this line. In Africa, she climbed the Mount Kilimanjaro in 2004. She is also conversant in French, Italian, and Portuguese. So I welcome you once more, and I pass the floor to Edith.
Thank you so much, Stephanie, and really it's a pleasure to be here. And I wish that I could draw on my Portuguese to present in Portuguese to you. Unfortunately, it is not that good, but I would love to visit in Brazil, especially in Sao Paulo, which I have never visited, and meet with you each in person and be able to practice a little bit more. So let me share my screen with you and we'll get started. Okay, so do you see my big yellow sign with the Sustainable Development Goal on it? Stephanie, is everything good?
Yes, everything is okay.
Excellent. Okay, well, I'm going to start out. Please don't hesitate to interrupt if we have any technical difficulties or if anything goes awry. But I'm going to start out with really my favorite representation of what we all do as energy professionals, which is not that much changed from the time that I used to work in the oil and gas industry. We all work to ensure access to affordable, reliable, sustainable, and modern energy for everyone around the globe. And I just love that that is captured by the United Nations Sustainable Development Goal number 7, which along with its 16 brothers and sisters is a real statement of how we as a global community want our world to evolve between now and 2030, which is getting closer and closer every moment. So I'm going to kind of build this discussion around that premise that we are all engaged in that goal to ensure access to energy for all. This is simply a representation of the flyer that was put together for this talk, and I have the abstract or summary of the material that I'm going to present on the left. And what I'm going to do today is share a few slides and thoughts on 3 different topics, and in between each of those topics I'll pause for just a minute and see if there are any questions or if anybody wants to see the slide again. And then we'll move on to the next topic. So that way we can all kind of not have to sit for 45 minutes looking at slide after slide. I also want to let you know that I have sent a copy of this slide deck to Stephanie, and I have encouraged her to share that with you if you would like to have the slides from our discussion. I ask only that you use them for educational purposes and don't share them for commercial purposes. So the first thing that I want to address is just what is this concept of the energy transition? What does it mean? And what's happening? Where are we in the energy transition? What's driving it? And how is it being affected by current circumstances of a global pandemic? And I think this set of graphs really reflects beautifully a snapshot in time in April of this year, 2020. And these data are all taken from the International Energy Association, which does a wonderful job of publishing current and accurate data and projections on a very timely basis and that are global in nature. So I encourage you to follow the IEA or go out to their website and download their reports. They are going to have another update in October to this material, so I would expect to see these numbers change somewhat dramatically. But the reason I share these graphs with you is whether we like it or not, and certainly it is a set of very trying circumstances from a global health perspective and a global economic perspective, but like it or not, we are in the middle of a great experiment in which demand for energy was simply dropped in March and April of this year. And so that has allowed us to kind of look at how energy needs will evolve if we're using less of it. And I think it's incumbent on us, even though it is a difficult time to go through, to look at the data as we go through and learn from the results of this experiment. And on the upper left, you see the projections of the IEA for energy demand drop for the most part on a global basis in 2020. And in April, the IEA was projecting about a 6% drop in total energy demand, with the bulk of that being in oil and coal, and only renewable energy having a small rise in demand in 2020 relative to 2019. And I think we are seeing, and we will see in October, that this pattern is going to continue because, like most global crises, the pandemic is acting as an accelerator of existing change. These changes were already happening in 2019, at the end of 2019, and now they are just happening faster. Of course, with lower energy usage of fossil fuels, we're also seeing a phenomenal drop, or we did see in early 2020, a big drop in CO2 emissions associated with the burning of fossil fuels. And to put that in context, this bar chart at the bottom shows the change in CO2 as a result of various world events. And you can see the significance of the pandemic in light of all the other relative changes, even from the Great Depression and World War II. This is a truly once in a century, if not once in a millennial event impacting our atmosphere. And finally, on the lower left, we see that energy demand growth is shrinking, not so much in those countries that were growing in 2019, but certainly in those countries, the developed economies that were already beginning to shrink in 2019. Now they are shrinking even more in 2020, as shown on the vertical axis here. So I ask you to kind of keep this global perspective in mind as we talk about what's driving the energy transition in the next few slides. And considering, and some of you have seen these slides before, but I think it's worth looking at them again. Considering, again, Global SDG 7, which looks at our overall job as energy professionals, really as geoscientists in particular, the things that are driving the energy transition, the fundamental factors affecting our choice of energy as a global population, are not that much changed from when we predominantly used fossil fuels. We still are looking for resource availability, efficient transition or efficient transformation of energy into usable BTUs, and of course cost is the ultimate controlling factor in what we use. This slide is a cartoon that looks at resource abundance, and in gray on the right you see total reserves of finite resources like coal, oil, natural gas. On the left, you see renewable resources. And in the middle, this gray dot that's labeled 16 terawatts looks at annual world consumption. Now, these data are from a decade ago. So now we're looking at about 20 terawatts, more or less, of annual consumption. So, of course, for the finite resources, that means whatever numbers we agree on or disagree on for all these reserves, we must divide that by how much we use each year, which will grow to 23, 24 terawatts before we know it. And that gives us a finite number of years for these total reserves. Whereas on the left-hand side of the diagram, we have the ability to put together a portfolio of wind and geothermal, maybe some biomass or hydro to readily meet world consumption needs with renewable resources. But of course, the really big resource is solar, which here, even although it has been scaled back to only represent that irradiance that falls on populated portions of the Earth during the right weather conditions and daylight hours, is still orders of magnitude bigger than what's required to meet world consumption. And of course, really, except for uranium, when we look at fossil fuels, we're simply looking at stored solar energy. It's just stored in the hydrocarbon bond as the result of photosynthesis, but it's used at a much faster rate than it can be stored. So from an abundance perspective, renewable energies are clearly the winners in a finite resource world. And when we look at efficiency, this is one of the factors that has changed really rapidly over the last decade and has pushed us into the energy transition at a faster and faster pace. If we look back in the 70s, we see that only a few percent of the energy that falls on solar voltaics or thin film solar or whatever type of solar technology we're talking about in these experiments, only a few percent were actually able to be converted to energy. Whereas today, if we look at these data aggregated, we're looking at almost 50%. So from 5 to 50%, again, an order of magnitude increase, and we continue to push that envelope, pushing for higher and higher efficiencies with more and more research and development. So having this happen over a quarter of a century to a 10 times improvement in efficiency is just phenomenal. I mean, imagine if you were able to improve the efficiency of any other process by an order of magnitude over 25, 30 years. That's a really, that's a game changer from an efficiency perspective. And of course, the final piece that is so important always is cost. And I share this slide with you from Lazard. Please do note that it is copyrighted. Lazard is a French consultant that tracks the levelized cost of energy for various electricity generators through time. And so what we see here is, of course, a general decline in most costs, ending up here in recent days with what I call the great triumvirate of solar, wind, and some forms of natural gas electricity generation being the lowest. But again, what's important here is not the absolute numbers, but the trend. In 10 years, we reduced the cost of solar from hundreds of dollars per megawatt hour to tens of dollars per megawatt hour. Again, imagine if you could build a building for a tenth the cost or drill a well for a tenth the cost in a time scale of a decade. So these two things combined, this enormous ramp up of efficiency on the one hand and dropping of costs to the basement, are what are really propelling us through the energy transition, which is being accelerated by the pandemic. The same thing is happening, these crossing curves of efficiency or installation and cost. The same thing is happening with lithium-ion batteries that power both EVs and storage of wind and solar. We are also seeing, again, a dramatic drop in price over 10 years, and it's projected to go even further faster. And as a result, installed capacity is just leapfrogging once we hit that low enough sort of $100 to $200 a kilowatt hour of storage. And in fact, this graph is woefully out of date. The last information that I saw that looked at even just plants that were being built in Europe for storage, we're looking at by 2025, 26, probably approaching 2 terawatt hours by that point in time. So every time a graph like this is published, it's wrong, and we tend to improve on the numbers with every new bit of data that comes out. So I want to now just take a minute, now that we've talked about, you know, what's driving the energy transition, and I want to share with you a little glimpse from one of the energy specialists at the Inter-American Development Bank on what's happening in Latin America and in Brazil in particular. So if you'll bear with me just a minute, it will take me a second to get this diagram up. Let's see. Okay, so I'm going to hit play on this in just a minute, and what we are looking at is solar PV generation in gigawatt hours over the course of that same decade we've been looking at in terms of costs and efficiencies. So starting in 2000, and you see the big players up here, and then everyone else sort of in alphabetical order here, with Brazil at the top of the alphabet. And suddenly, in about 10 years ago, we're going to see the first megawatt hours in Brazil, and it's hovering in there in the single digits. And then as we cross into the last 5 or 6 years, boom, suddenly there you are, up with the big three, and looking at, about approaching 5 terawatt hours of generation from solar PV alone in 2019. So like so many other countries around the world, but particularly in South America, I wanted you to see how Brazil has taken this position of ownership in renewable energy, right up there, a close second behind Mexico and Chile. So I'm going to come out of this and back to this, and then I'm going to stop sharing my screen for just a few minutes, if this is a good time to pause, and see if anybody has any questions or would like to see some of those slides again.
Okay. If anyone has a question, you can just open your microphone and your webcam and do the question directly.
Edith, I have a question, but maybe, I don't know if you work this in the next slide, but I have a question. So I would like to know about when you work about the word acceleration in the context of the energy transition. Because for me, this work now, a lot of people have been used it, and I think this will be consequences, several consequences. So
Yes.
what do you think about this?
Well, I think that there are two factors. You know, one is that aside from the pandemic, the pace of change for energy technology in the renewable side of the equation is so much faster than for fossil fuels, because instead of making change in a mechanical, physical, extractive process, the improvements in efficiency and lowering of cost in batteries and solar and wind, most of those are truly technology changes. So we're looking at Silicon Valley style rates of change. And so the faster they change, the more they accelerate, right? And so this is something that it's really hard for people like me who spent their career in oil and gas. It's really hard for us to get used to that accelerating pace of change, just because you're looking at technology development, at AI, at improved storage, at improved chemistry, at things that can change at a really fast pace. But then when you look at the pandemic influence on that, then we also see that when we stop buying energy, when we stop buying cars, when we stop buying gasoline, when we make the decision to do so again, we're going to be even more cost conscious. So that's going to push us to those lower cost solutions. So I think there really are a number of ways in which the pace of change is accelerating through the transition.
Okay, thank you.
You're welcome. So I'll just tell you what my next bit is going to be on. I'm going to talk at this point, and you'll have to forgive me, I'm going to slide into my geology role a little bit, but I want to explore for a bit the fact that as we go through this energy transition, there's tremendous potential for us to bring our skills directly from the old energy business into new energy businesses. And there also are, and of course there are declining opportunities in the old energy business as well. It is a two-sided coin. But there also are new wedges of opportunities that are going to open up. So I'm just going to kind of lightly touch on some of these, and I'll try not to get too deep into the geology, and with apologies to those of you who are historians and engineers. But we all love maps. So I'm going to start out with, the last thing we talked about in that first set of slides was the need for more and more energy storage, not to mention building solar and wind facilities. But for energy storage in particular, we need a group of minerals that are not necessarily in ready supply equally all over the globe. And so it's going to fall upon us as geologists, as engineers, as material scientists, as procurement specialists and project managers to source things like graphite, which makes up the anode of the battery. It's most of what's in those big car batteries by weight. That's mostly graphite. Lithium, which goes into the layered lithium oxide structure on the cathode side, and cobalt, which is layered in with the lithium on the cathode side. And so these maps that you're looking at show that the distribution of deposits in the little dots and mined production in the colors of the countries. So for example, if we look at graphite on the upper left in pink, you see that there are a number of known graphite deposits in the US, but we don't mine any graphite at all. Whereas in Brazil, there are a number of graphite deposits, and Brazil mines, I think, about 10% of the world's graphite. By far, most of the graphite comes from China. It's mined in China. Lithium is mostly mined out of pegmatites in Australia, and to a lesser degree in China, and in the lithium triangle in Bolivia and Argentina and Chile. Again, Brazil has some lithium deposits and does a little bit of lithium mining. In cobalt, the story is very skewed. Most of the cobalt is mined in the Democratic Republic of Congo, but notice that there are cobalt deposits in the US and in Brazil, although actually this is incorrect. There's no mining of cobalt today in the US and none in Brazil. So as professionals looking for these resources, turning those little dots into production is going to become really critical if we're going to be able to meet this supply chain. And the skills that we're going to use, and again, I apologize for the geology, but the skills that we're going to use, I'm showing you some maps and cross sections and geochemical diagrams from the Katangan copper cobalt belt in Central Africa in the Democratic Republic of Congo. And these sorts of evaluations are exactly the same things that we are doing in the subsurface in the fossil fuel industry. So there is a direct connection from those who are collecting data, mining defining play fairways. We can take those skills one-on-one and apply them from the old energy world to the new. And I always like to put a face on this. And so I want to introduce you to two colleagues of mine who are very open to connecting and talking about their careers. So if you are interested in the mining industry, whether you're a geologist, an engineer, or a marketer, or whatever, both of these young professionals are very eager to talk about their work, and they also have a very broad perspective on the whole range of the business. Lucy Crane works with a company called Cornish Lithium, which is extracting lithium from geothermal brines near the old tin workings in Cornwall. And Jesse Edmondson is an American who has started a small business here to try to begin to mine some of these critical minerals in the US. So both of these folks would love to connect with you on LinkedIn and answer any questions that you might have about the mining side of the business, where we can transfer our petroleum skills into new energy resources. The other very obvious place that we can do that is with geothermal energy. Now, you may have noticed that geothermal energy on the cost side has not come down enough to make it really take off the way that solar and storage have. But costs are becoming lower and lower, and so these deep geothermal projects where we drill in areas of high geothermal gradient, like the northwest of the US, or the trenches in Japan, or the Circum-Pacific Ring of Fire along the west coast of South America, these deep, hot geothermal projects, the costs are coming down. But even more importantly, we're starting to view geothermal very differently. We look at all of the depths and temperatures in the earth as places that can supply heat. For example, in a geothermal ground source heat pump, a home or a group of businesses can very efficiently and economically heat and cool their buildings with a simple ground source heat pump system. And now we're seeing great interest in the so-called warm geothermal areas of the world, the sedimentary basins where we've been producing oil and gas for all these years. And as we produce those fluids from the subsurface, what comes up with the fluid? Heat. And we just waste it. As a matter of fact, we have to take proper precautions, so that it doesn't cause damage to our infrastructure and to dispose of it properly at the surface. So we're seeing a resurgence in research at this sort of intermediate scale to try not to waste the heat from existing infrastructure that we already have in place. And of course, drilling skills, engineering skills, project management skills that people have been using on these sorts of projects in oil and gas for years and years are one-to-one applicable to the geothermal world. And Taylor Maddie, who's one of the faces I want to put in your hands on the geothermal side, is perhaps the best example of that. Taylor is an engineer with Baker Hughes who has worked in oil field services but now is the product line manager. He has a master's in geothermal from Auckland. He's now a product line manager for Baker Hughes and manages their global geothermal business. So again, he's someone, if you'd like to talk about that marriage of infrastructure across old and new energy, Taylor is a great guy to talk with about that. And Merit Bromer in Germany is head of the International Geothermal Association, which is kind of like the AAPG for geothermal workers. And so Merit has her finger on the pulse of what's going on all over the world, whether it be deep, hot geothermal in Iceland or ground source heat pumps, which are being used more and more throughout Europe. And there are a number of really fascinating startup technology development firms that are, everyone is just trying to use the heat we have. And there's a tremendous gain to be made in reducing carbon emissions through these efforts. And the final piece that I'm just going to touch on lightly here, which is, again, a direct one-to-one translation of skills from the old energy world to the new, is carbon capture and storage. Because these same reservoirs, and I didn't bore you with geology pictures of the reservoirs, but the same reservoirs that we've been using all our skills to understand and find the open pore space in to produce oil out of, these same reservoirs are now being used to store carbon dioxide safely. So whether it's the giant Northern Lights project in the North Sea, which is a collaboration between Equinor, Shell, and Total, and their technology center at Mongstad, or it's BP in Algeria, they're turning their In Salah gas field into a carbon storage project, or Chevron in Australia at Gorgon. And there also are a number of US projects, either for research or for EOR, to still produce oil but leave the carbon dioxide, capture the carbon dioxide and leave it in the ground. So this is yet a third place where exactly what energy professionals were doing in the old energy world, they are now doing in the new energy world. Runa Thorsen is with Equinor and runs a reservoir management team pushing CO2 in instead of taking oil and gas out. And Autumn Hagsma works with a research group at Battelle in the US, and she works with seismic data, with wireline logs, with well records, with core data, exactly the same workflows and processes that we use for reservoir characterization in oil and gas. She also uses in her work on CO2 sequestration. So again, just a couple of friendly faces. If you're curious about carbon capture and storage and whether there might be a role there for you in the future, these are two people that you can certainly connect with and ask questions of. Now, there's another huge wedge of opportunity out there, and it is in an area that the little graph on the lower right is from the AGI that looks at global geoscience workforce every decade or so. And they are predicting that mining and oil and gas extraction will shrink, but that overall the geoscience workforce will grow, and it will mostly grow in risk management and supportive activities. So all of that supply chain work with mining, there'll be a few geologists out there exploring for new deposits, but mostly they'll be working on the processing side. And they'll also be working in things like engineering and project management for energy infrastructure development for new renewable resources, building livable cities. Of course, there's going to be a lot of work in solar startups, in utility, artificial intelligence, and optimization of energy between the grid and the battery in your car and your garage through your cell phone with some sort of AI overlord watching everything. So there's a lot of exciting work going on there. There's also a wonderful opportunity for us to put our skills that we've learned in the energy business to work in climate change, risk management, and mitigation. And let me show you an example of that. We haven't even talked about the hydrogen economy and the opportunity to do something with hydrogen. That's probably an entirely different lecture with someone who knows more about it than I. But I also want to encourage those of you who are still working in fossil fuels that there are tremendous efficiency and cost opportunities to greening the oil field, to stripping lithium from oil field brines, recovering vapor instead of flaring it, and using these cheap renewable energy resources to lift fluids, to pump fluids from the ground. It's now much cheaper to build a little battery-backed solar installation than to string electricity out to the oil field. So I'm going to talk about these two in bold that kind of fall within the pink circle on the AGI workforce projection, and introduce you to one last colleague who actually got his master's degree from OSU in Stillwater, like as we were talking about before we began. And Kevin had a petroleum geology degree and had been working with horizontal drilling programs in the Anadarko Basin, and then completely turned his career in 180 degrees and is now working in Manhattan with one of these global livable cities firms that's building resilient cities across the globe. So Kevin never really knows what he's going to do from day to day. One day I called him and he was doing bedrock mapping for the high-speed rail that's being built between San Francisco and Los Angeles. The next day he's doing water quality assessment or some project management for construction. So, he loves that because he loves the variety and the diversity and the opportunity to be kind of on the bleeding edge of what's happening around the globe. So I think there are going to be any number of new opportunities in this realm. And if the pandemic provides you with some space to do something that is a little different from your usual paid professional work, I want to encourage you to consider community science. And I have worked, the map you see on the right here is one that I made on a project I worked with through the American Geophysical Union, where after Hurricane Harvey in Houston, we worked with community organizations to map their flood infrastructure issues and to help them advocate for funding and for remediation for the damage after the hurricane. And there will be many, many more projects like this as climate change continues to unfold. And I'm sure that there are other organizations besides the AGU which also do this. What I love about the AGU is that they are very broad in their science. They do everything from planetary science to surficial processes, but they also are very diverse in their outreach to global communities of color, to all genders. They are dedicated to building a community for the future that is truly diverse and expansive and inclusive. And so I just recommend that you kind of think about partnering with a community on a project. I went out to their website to sort of see what was happening and found that one of their new projects is looking at rivers and sustainability in the Dominican Republic. They are not just US based, they are all over. And I'm sure there are many, many wonderful community science opportunities like this all over the world. But if you're interested in looking a little more at Thriving Earth Exchange, their Community Science Fellows program starts in January, and the application is now open through the end of October. So, when we think about how we're going to use our skills, not just in accessing energy resources, but in turning the corner of the energy transition and taking the carbon equation to zero, there are many, many things we can use those same skills for: drilling, project management, mapping, in climate mitigation and risk management as well. So I encourage you not to forget about that little bit. My next piece is going to be looking at the full supply chain and what we need to do to ensure its sustainability in what is becoming a very circular economy. So I'm going to talk about that a little bit with the remaining time, maybe another 10 or 15 minutes of slides. But I'll pause here. Does anyone have a question or want to see a slide again before we go on?
Okay, everyone, if you have a question, you can address it directly or we continue.
And if you're all enjoying a nice glass of wine and just have your feet back and you'd like for me to continue, I'm happy to do that, but I'll pause for just a minute to see if there's a question.
Okay. I do have a question. Now that you said, how are we going to use our skills as young professionals? Once I heard from a very known professor that it was kind of promoting the lithium mining from Bolivia in order to strengthen the electric vehicle market here in Brazil, looking for the electrification of our mix. But then I start thinking that this can become a very geopolitical issue because we are just trying to mine a poor country in order to achieve an energy transition here in Brazil, but we are doing like some harm to the other country. So my question is, what are your thoughts on this? Because this is just a particular example between Bolivia and Brazil, but this can be just new dynamic, a geopolitical dynamic between a poor country and a developed country. Once again, repeating the energy history.
And you actually are, I'm going to flip back to this slide, but I am going to come to that in a very definite way as we talk about supply chains at the end of the talk. But I want to set us up for the full answer to that question by reminding you that on this map, in the case of cobalt, that is exactly what our current state is. 2/3 of the cobalt that we need for global electrification, for all of the batteries, for all of the electric vehicles, and all of the storage for wind and solar, 2/3 of the cobalt comes from artisan mines in the DRC in the worst conditions. Almost 2/3 of the graphite comes from China. So we are trying to electrify the world with these very difficult geopolitical decisions. So in essence, where we are right now, our current state is just as you described, exploiting those countries for their mineral resources to try to make this energy transition. So what I'm going to premise for you as we go forward is that it's incumbent on us as energy professionals to look at the entire supply chain and to make it more abundant worldwide, more efficient, which means more local, getting our graphite perhaps that we use in the US from US deposits, the graphite for your batteries in Brazil from your Brazilian graphite mines, etc. So we want to make it more efficient, which means more local. And we also want to make it, of course, lower cost, which means the application of technology. But we also need to make it more sustainable, which often goes along with low cost, using solar to power our mines instead of fossil fuels, because it's both more sustainable and lower cost. So I'm going to talk about that in the next section, but this kind of gives you a picture that situation that you described is exactly where we are today. We have set up this geopolitical nightmare of all of the resources being controlled and accessed through some very unsustainable practices. So that is indeed what we need to work on. And I am hopeful that we can take our perspective from past experiences and do it better. So let me show you the last few slides that I have. And we'll get right to the heart of that question, and then we'll have the remainder of our time together to have an open discussion. So again, this last part, I'm going to really focus in on the supply chain and how do we develop new energy resources that will both drive the carbon budget to zero, but also keep this sustainable environmental and social integrity in place. And it is not a small task. I don't mean to trivialize it, but I think that this is in fact our task. This is our mission as energy professionals. This is what we need to do, is we need to ensure the sustainability of that supply chain for renewable resources, because there is one. This, for example, is looking at that whole battery supply chain for lithium-ion batteries, just what we were talking about. And as you can see here, one thing we didn't talk about earlier is it's not just mining. There is certainly mining that requires energy professionals, young professionals, experienced professionals to find and extract resources through mining, whether it's manganese, lithium, cobalt, nickel, whatever, graphite. But there also is a huge step of refining and processing before we even begin to make the batteries. And then the batteries have to be produced first with chemical procedures in cathodes and anodes, and then in a manufacturing procedure with cell production. The cells need to be assembled into modules, and finally into the manufactured automobile or battery for storage. So in each of these steps all along the way, there is potential for better sustainability, better efficiency, lower costs, better applications of technology. And so you can imagine the amount of skill that's required to work all the way along the battery supply chain, and for all of these minerals that are going to grow dramatically in demand as we build more and more and more. Remember that battery installation curve just going up, up, up on that right-hand axis. And what I want to emphasize in this slide, which is from my friend Jesse Edmondson, whose picture I've shared with you, is that if we look at raw materials for these batteries, and this happens to be graphite, we dig it out of the ground, we separate it into a concentrate, and it has a little bit of value there, sure, $800 a metric ton for this kind of concentrated 95% carbon graphite. But the product that Volkswagen wants in their battery, back here where they're producing cathode or producing anodes out of the graphite, the product that each manufacturer wants is very refined, it's very advanced, and has to go through a number of steps of refining, whether it's Elon Musk wanting a perfect flake of a certain size, or maybe it's LG out of South Korea needing an exact little spheroidal diameter. These materials are bespoke. They are individually tailored to meet the needs of batteries. It's not like crude oil, where we take a barrel out of the ground and it goes through a fairly common refining process and boom, into the car. Most of the value, look, again, an order of magnitude jump. When we get to 99.99% pure carbon, now we're talking an order of magnitude greater value. So an enormous value adding step in here. So just keep that in mind, that we talk about making the mines themselves more sustainable, more efficient, more commercial, more environmentally friendly. But that's only one piece of the puzzle. It's this entire supply chain for all of these minerals and all of these processes that we as energy professionals now have as our charge to keep this on the road to sustainability. And what you'll hear in this phrase often is the circular economy. We're working towards a world where we don't just look to extract material one time, as in the the previous slide, we look at every piece of the business, and this is a diagram from Schneider Electric, who has, as you can see from the little sidebar here, has circular activities accounting for 12% of its revenues. That is not insignificant. So what this means is they are looking to every part of the supply chain for material efficiency and resource usage. They are looking to reduce and reuse waste, to monetize their waste, to mine their waste. Piles of electronic waste have a higher ore grade of gold than most mined gold deposits today. So it's incumbent on us to look everywhere for materials and to look in the ground and extract them last. I love what Jean-Sébastien Jacques of Rio Tinto, the CEO there, says. Society expects more of our industry. Another way to look at this is we have another opportunity to do the energy resource supply chain better than we did in the last energy economy. So absolutely this guardianship of the energy supply chain is critical to any work we do in the future. And I show you this diagram from a variety of data sources, and you should take these numbers with a grain of salt. They're by no means exact, but they are illustrative of kind of a calculator of, in this case, CO2 equivalent per kilowatt hour of electricity generated. We could also make the same calculation using lithium, how much lithium is used. And believe me, there is lithium in the sensors, in the batteries used in the oil field that for gas and for coal. But we could do a similar calculation on any resource. But this one, so many people do calculations in CO2 equivalent. See that I was able to pull this together. And what you can see is that because there is direct generation of CO2 from hydrocarbons, we have a much higher average CO2 equivalency per kilowatt hour generated from hydrocarbons than, for example, say solar. So again, an order of magnitude improvement in sustainability going from hydrocarbons to renewable resources, but by no means are we going to zero. Whether we're talking about geothermal, hydro, wind, solar, in all cases, we're looking at some burden of carbon in this case, some burden of resources to make that renewable energy. So we can't just say, job's done. We've got cheap solar now, we're not, we're sustainable. We always have to be looking at this burden on the supply chain of CO2 or lithium or whatever it is. We always have to be pushing this to be better and better than we were before. And why do we need to do that? Obviously, I mean, you're all familiar with this particular map is sea surface height change from NASA, with everything in red being rising sea level. And of course, as energy professionals and students, we all know that as we have moved through the hydrocarbon chain from heavier wood and coal to lighter oil and methane hydrocarbons, we improve a little bit. We emit a little less CO2 and a little bit fewer pollutants, and we gain a little bit in energy efficiency. But nonetheless, the breaking of this hydrocarbon bond has correlated with rising surface temperatures and rising sea levels and the horrible effects of climate change. But the question that was asked earlier is really at the heart of this for me. Along with this damage to the environment from hydrocarbons has come a tremendous inequity in energy usage and carbon dioxide emission. This is from Oxfam in 2015. I'm sure it was even exacerbated before just before the pandemic, and I would really love to follow these data as the energy transition unfolds. But you can see that according to Oxfam 5 years ago, the wealthiest 10% of the world's population was responsible for almost half of the total lifestyle CO2 consumption emissions. So what this means is that 10% of the world was using 50% of the energy and emitting 50% of the CO2. And so when I say we must do better, it's not only that we need to clean up the supply chain, we need to equalize, provide energy equity and distribution of energy across the global population at lower carbon consumption per capita as well. And what excites me about the energy transition is that I think the technology and the way it works and the speed at which it improves in efficiency and cost gives us an opportunity to do that. And what I mean by that is the distributed energy model, and I'm showing you here on the upper right, a Google Earth image of a small settlement called Kyamonde outside of Cape Town, South Africa. And Kyamonde is one of many high-density population areas outside of cities that is completely unelectrified and no hope of ever creating a grid with wires to every one of these small homes, no way of getting a natural gas distribution line to the millions and millions of residents of Soweto, for example. But look closely and you will see that each small home in this community has a solar panel on the roof. And that is not happening because an NGO is going in and giving each of these homes a solar panel. That's happening because companies like Schneider and Tata are building their market with distributed energy resources through training, through cost plus sales, through small business financing, because this distributed energy model, it's cheap components, it's easy to install, it's fast, it spreads like wildfire. So our potential to actually provide energy equity and electrify and under-electrified parts of the world through distributed energy resources is much enhanced by the energy transition. We cannot say the same for the energy supply chain, though. So here is a cobalt mine in the DRC, where the cobalt is coming from, again, a much smaller component and a much more sustainable component in that it doesn't have to be replaced for every erg of energy generated. But nonetheless, this progress is being fueled by the inequity of the supply chain of the critical minerals. So that is our work to be done. That is definitely our work to be done. And the last couple of slides I want to share with you are just a few thoughts I have on sort of things I can do. What can you do? You know, how can I make sure I don't miss an opportunity to do the job that I know I would just love as this energy transition unfolds? And here are just some suggestions, and these are very personal from me. Change what you read. Read things outside of your usual scope. If you're used to reading Oil and Gas Journal or one of the industry rags, read a utility journal. Read Bloomberg New Energy Finance. Read the bank newsletters that are financing the green energy projects. Read something that isn't in your comfort zone. And that will help you to expand the landscape of opportunities available to you. So you'll also want to explore other industries and companies, you know, instead of always just chatting about what Shell is doing, you know, think about what Engie is up to. And most importantly, and I know this is preaching to the choir, but connect with others and learn from them. And most importantly, as you connect with others and learn from them and take advantage of their connections, make sure you look behind you and reach the hand behind you. Do as our wonderful American author says, don't go where the path may lead. Go instead where there is no path, but leave a trail. Bring people with you. When you have a great opportunity, look for a student younger than you or a professional younger than you that you can help with their own opportunity. So when I say read a bunch of different stuff, you know, these are some of the things that I read. Green Tech Media, which is a WoodMac product. Some of this stuff can get pretty scary. Utility dive is a great one for understanding what's going on in big energy installations around the world. I mentioned Bloomberg New Energy Finance. Even S&P, has some great renewable stuff. And some of it is very frightening. I mean, BP sells their entire petrochemicals business. Wow. Things are changing and accelerating very rapidly. So I encourage you to really branch out on what you read, and what you'll find then, and this is very US centric, I apologize, but even so, you'll see some names you recognize here. What you'll find is that in this world of the energy transition, and this is looking specifically at microgrids, which are not just catching on in high density populations in unelectrified parts of the world, but also in small communities all over the world, including in the US, you'll find not just Shell and Total and some of the big guys, Siemens and Schneider should be in here somewhere, but you'll find BlackRock that used to fund oil and gas. You'll find NextEra, which is building some of the biggest wind solar storage projects. Of course, NG, I'm sure you recognize many of the names on here. But you're going to have to get used to starting to look at some company names that might not start out very familiar. And I just, right before this discussion, just pulled up my network on LinkedIn. You'll see some of your names on here, and just selected for my first connections I didn't even select for second connections, but first connections in Brazil, and there you are. And I had an opportunity, just as an example, last year I was looking for a speaker on distributed energy resources, and I happened to know that Schneider was a big company in this, so I called a colleague I had worked with in South Africa on a similar project, and he referred me to João in Sao Paulo, and João is the manager of sustainability for Schneider. So, with your ability to reach out through LinkedIn, you can connect with people in a field or an area or a country or a business or a company that you knew no one at, but now you can say, Jean, Edith told me that you might be able to point me in the direction of some companies that are putting distributed energy resources into Sao Paulo. Can you help me out? So this is what we can do for each other, is share these connections. And I leave you with this final thought, which I love, that as we look at the energy transition, it's not something we're going to have to really work for. It's already happening. The world is actually already overrun by cheap and plentiful clean energy. It's really a question of how do we adapt? How do we adapt as professionals to recognize these opportunities? And more importantly, how do we adapt as global citizens to do a better job of the energy supply chains and really realize the promise of energy equity and economic equity that this transition holds the promise of. So that's the end of my prepared remarks, and I will stop slide sharing, but I can go back at any time if you need me to.
Thank you, Edith, for your presentation. Always a pleasure to hear
You're so
you.
welcome.